Yet another problem considering different reference frames. So an elevator car whose floor to ceiling distance is equal to 2.7 meters start ascending, that is going upwards, with constant acceleration 1.2 meter per second square. 2 seconds after the start, a bolt begins falling from the ceiling of the car. Find first of all the bolt's free fall time. So let's draw the scenario. This is, let's say, I'm drawing the elevator as a box. This is a bolt that starts falling from the ceiling of the car at t equal to 2 seconds, considering the lift started going up at the so after the starts, right? So at t equal to 2 seconds it starts falling, right? Now if we stand on the elevator, so elevator frame of reference, if we take this, then in the free fall time, let's say we take the downward direction as positive, so displacement is in that case 2.7 meters. The obviously the initial velocity is 0, so the stationary initially with respect to the lift of the elevator, and the acceleration is actually, so what is happening is already for the free falling bolt with respect to, so it is, so acceleration, I'll just use it, acceleration of bolt relative to the elevator, acceleration of bolt minus acceleration of elevator, right? Acceleration of bolt is, it's in free fall, so 9.8. Acceleration of elevator is accelerating 1.2 meter per second square upwards, right? So this means it is basically minus 1.2. So this means it is 11 meter per second square, right? Right. So now we know that S is equal to ut plus half a with respect to e. Everything is with respect to the elevator. This means S is 2.7, 0 plus half a of b with respect to e is 11 into t square. Okay, so this becomes t square is equal to 5.4 by 11, which is roughly 0.49. That would have been 0.5, it was 5.5 by 11 would have been, yeah, it would have been 0.5, so it is 0.49. So t is approximately equal to 0.7 seconds. This is the first part done. Now moving on to the second part, they are asking the displacement and the distance covered by the bolt during the free fall in the reference frame fixed to the elevator shaft. Now very important point, elevator shaft means the basically the stationary sort of pathway of the basically the elevator. So it's like to the relative to the stationary frame of reference, the ground frame of reference, what is the displacement and the distance covered by the bolt, right? So let's see, so let's find out displacement first. Okay, displacement with respect to ground frame of reference. So now let's call it S. This will be equal to, S is nothing, so let's call it like S because we already used up S, right? Okay, let's call it D. There's no confusion. D will be basically D of the bolt, obviously, right? or okay, let's call it by S because D could mean distance. S of bolt is equal to S of bolt with respect to elevator plus S of elevator, obviously with respect to ground. Nothing is mentioned, it is with respect to the ground. S of bolt with respect to elevator we already know, and again this direction is positive, a downward direction, right? So S of bolt with respect to elevator we already know that it is 2.7 meters. We need to find out SE, right? So SE is nothing but is the distance covered between 2 seconds and 2 plus 0.7 because that is the free fall time. So distance covered between 2 and 2.7 seconds, distance covered by elevator, and obviously initial velocity is 0, so it becomes half a. Half into a is basically the acceleration of the elevator, which is 0.2. So 1.2 since we are subtracting, it will become 0.7 square minus 2 square, right? This will become half into 1.2 into a square minus b square is a plus b into a minus b, right? This becomes, so this and this becomes 0.6. 0.6 into 0.7 is 0.42 into 4.7. Okay, so what is this? 4.7 into 0.42. So 47 to the 7 to the 14, 4 to the 8, 9, and 4 is just the twice of this number, which is this becomes 4 and 17, 9, and 3 decimals, 1.974. So 1.974 is SE. SB comes SB with respect to E. With respect to elevator is obviously the elevator height 2.7. And okay, so one thing I made a small mistake, that SE is basically, so the elevator is moving upwards, so it has a negative sign because we are taking downward direction to be positive. So moves upwards from 2 to 2.7 seconds, right? So this becomes minus 0.974. This becomes approximately 2.7 minus 2 is 0.7 meters. So basically the displacement, there is a displacement of the bolt in the downward direction, which is 0.7 meters. Now one thing has to be clear. So when especially when we calculate the distance, so why are they asking two separate things? That also will become clear now. So why the distance? So if we consider it from the ground frame of reference at t equal to 2 seconds, the elevator has certain upward velocity, right? I mean, yeah, let's call it some, I'm just calling it some arbitrary v naught, right? So with that velocity, when the bolt dislodges, it goes upward also with that velocity since it was in contact, but later, and now it is in free fall, right? So it goes upward with v naught. So since it goes upward with v naught, and we already know that it has a net displacement of 0.7 meters with respect to the ground, what happens is it takes a trajectory. Of course, it goes up, comes down. Now in the meantime, this elevator rises up by a certain distance. and at t equal to 2.7 seconds they collide, and obviously the displacement of the bolt, which is this is 0.7 meters. Now if we are able to find out, say, this distance, this height h, and multiply it by 2 and add 0.7 to it, so 2h plus 0.7 meters should be the total distance. It goes upwards and it goes down, right? So it goes up by h, it goes down by h plus 0.7, so basically 2h plus 0.7 meters will give you the distance covered. Now we need to find out h, and we know that when a body is thrown upwards, the h, so you can very easily calculate that. The initial velocity is, so if we consider we are considering everywhere the downward direction to be positive, so minus h is equal to, right, because yeah, displacement is in the upward direction, minus h is equal to, so it okay, so rather we should consider the equation v square minus u square equal to 2gh. So initially at t equal to 2 seconds, when the bolt dislodges, it has some velocity, let's say v naught. It's very easy to calculate, but for now we'll keep it at v naught. So at the start of the free fall, it has a velocity of v naught. At the peak height of the bolt, the velocity becomes 0. So final velocity is 0 square minus v naught square, right, because it's square, so it doesn't matter whether it is plus v naught minus v naught, is equal to 2 into g into, but displacement is in negative direction, minus h. So this means h, negative sign cancels out, h is equal to v naught square by 2g, right? Okay, this means the distance equal to, as we already know, it is 2h plus 0.7 meters, so 2 into naught square by 2g plus 0.7. So 2 cancels out, it becomes just v naught square by g plus 0.7. Now v naught, what it would be? So it is basically the velocity, magnitude of the velocity of the bolt which is dislodged at t equal to 2 seconds, which is essentially the velocity of the elevator at t equal to 2 seconds, which will be v is equal to u plus at, u is 0, a is 1.2, t is 2, divided by g, which is 9.8 plus 0.7, right? So which is 2.4 times 2.4, 9.8 plus 0.7. This roughly goes 4 times, and this goes 0.6 times. So 0.6 plus 0.7 gives you, plus 0.7 gives you 1.3 meters. This is the distance covered. Hence we got the free fall time, the free fall time, the displacement, and the distance of the free falling bolt from the time it was dislodged from the elevator to the time it dropped to the floor with respect to the elevator shaft or the ground frame reference. So yeah, that's that. Thank you.